So this is a arbitrary question.
Yes, sir, arbitrary.
And
N to W, whole numbers, set of whole numbers. So N union 0. And F satisfies this F of AB, F of A times B is equal to F of A, F of B if GCD AB is 1. And they have also given that there exists a prime P naught
P naught, a prime.
such that, yes, sir, prime, such that F of P naught is not equal to 0.
Mhm.
And they have also given that F of P plus Q is equal to F of P plus F of Q if P and Q are primes.
Right.
So, sir, actually, there are two questions. One question is the question that was asked on Stack Exchange, and like the second question is one that I've made myself. So, the first question is show that f of 2 is equal to 2.
Okay. So let's do this first.
So, this is what they've asked, and this I'm able to do. But then,
So
my
how do
question
you?
is
Okay.
okay, yes, sir. So, suppose P naught is not equal to 2. So, two cases we have.
Okay.
So, if P naught is not equal to 2, uh, then f of 2 P naught.
Mhm.
Now, since GCD of 2 and P naught is 1, we can write this as f of 2 f of P naught.
Right.
And this 2 P naught, this argument, it can also be written as P naught plus P naught, sum of two primes. So we
Right.
can say it is 2 f of P naught.
Right.
And P naught, f of P naught is not 0, so we can cancel, and f of 2 is 2. So this is, now if P naught is equal to 2, so then we have f of 10. We have to consider f of 10.
Okay. F of 10. Okay.
Yes, sir. F of 10, we write it as f of 2 times f of 5 because 2 into 5.
Okay.
But then we can also write it as 2 times f of 5 because 10 is 5 plus 5.
Mhm.
Now, suppose f of 5 is 0. So we show that f of 5 is not equal to 0. Now, so for contradiction, suppose f of 5 is 0.
Mhm.
Then f of 5 is f of 2 plus f of 3 because 2 plus 3.
Hmm.
F of 2, yes, sir.
Mhm.
Uh, is equal to 0. So it should be a plus there.
Right.
But now the range is n union 0. So this can only happen when f of 2 and f of 3 are both 0.
Hmm.
But f of 2 is given to be not 0 because p naught is 2. So this is a contradiction.
Okay.
Uh,
Right.
So then from above we can cancel f of 5 and we get f of 2 is 2.
Right.
Oh, and one more thing, sir. In the question, They've given f of 1 is 1. So that is given. Yes. Yes, sir. So now my question is f the identity function? So that is what I.
Okay. So this is fine. F of 2 is
Yes, sir. So we can also show that f of 3 is 3.
right. Okay. I understand. That will be the what is special about 2 here? Little bit special.
Sir?
Yeah, means the way you showed f of 2 is 2, you
Yes, sir.
can show similarly or how?
No, I mean, I build on top of that. Like to show that f of 3 is 3, I need f of 4 equal to 4, then I need f of 12 and all of that. So like that, I can show f of 3 is 3. And then from that, many follow.
Right.
So for now, we have f of 1 is 1, f of 2 is 2, f of 3 is 3, f of 4 is 4. So same way it works for 5, 6, 7, 8, 9, 10, 11. So like that.
Okay.
So sir, my approach was I was thinking of induction. So it is true for 1 through 10. Like you can show that. So for so I treat those as my base cases, and then I assume it is true for 1 up to k for some k greater than 10.
Right.
So so it is true for 1 up to k.
No, but how will you use that group for k plus 1?
So I actually get very close using that, I think.
Okay.
So what I do is I assume it's true for 1 up to k.
Okay.
Then k plus 1. If k plus 1, yes, sir.
But just 1 minute. The way you showed f of
Yes,
2
sir.
is equal to. So what was the main thing there that if f of p naught, yeah, if 2 is not equal to p naught, then it's very simple.
Yes.
If p naught is not equal to 2, then it was simple, right? So
Yes, sir.
if right, so if basically then if there is any prime q which is not equal to p naught, then
Yes, sir.
also we can say that then yeah, but it will not be like
But we can't write it as p naught plus p naught. So like that.
right. You cannot write it as p naught plus p. That is a difference. Uh,
Yes.
yeah, this is a very strange condition.
So actually the question, it was not well written. So like what they just gave if p and q belong to capital P. So like I'm assuming that capital P is a set of all primes, and I'm
Yes,
seeing if
I think
that's
yeah,
what they meant.
it should be that way. Just 1 minute. So this thing is yeah. So this applies to all primes. This applies to all primes. So
Yes, sir.
why cannot we prove that it is like this? Then this is uh, also true.
So how is
Okay, this is not true. Uh,
so how do we go from this, because p plus p won't be prime then, like how do we
oh,
apply
yeah,
the
yeah, that is not true. Okay. Okay. So then how do you, let's see then.
Yes, sir. So I assume it's true for some n, and here n is greater than 10.
Hmm.
So because we've covered those base cases, and
Right.
now if n plus 1, if n plus 1 is composite and it is not a perfect prime power, so we're assuming that is one case.
Yeah.
So then what we
That
can
is
do,
done. That case
yes,
is easy.
that is done.
Right.
Yes.
So this
But
is if let's so
yes,
if n plus 1 is not that, I mean, I think prime powers are a problem.
yes, yes, so prime powers are the problem.
N plus 1 is not a prime power. N, yeah, so not a prime power means that it's we are uh, yeah, right. So that case is done.
We can write it as AB with that GCD condition fulfilled.
Right, and then we'll be done. But that is the problem. If it's a prime power, then that's where the problem comes. Right?
Yeah.
E to the power.
If it's prime also, I have a method, but this prime part I'm not able to
Okay.
resolve.
So if it's a prime, then what do you do?
So if it's a prime, so then n plus 1 plus 3. So actually n plus 4. We consider n plus 4, and n plus 4 will
Okay.
be
I
even.
got it. I got it. Then you take it back.
Yes, yes, yes.
So that is
And
also
n
done.
plus 4 will have factors in 1 to n.
Yeah, yeah.
So then 3 and n plus 1 are prime, so we are done with that.
Right. So that is fine. So yeah, then you basically move a little bit up and then you go down. So why can't you do the same thing with, let's say, p square?
So 27. So like we're not confirmed to have like a prime decomposition. So like 27, you can't write it as sum of two primes. So like I still don't know what f of 27 is.
Right. But right. Okay, no. So just can you tell me once again how you do f of p equal to p? Because how you say this?
Okay, yes. So suppose n plus 1 is prime.
Mhm.
So then it's an odd prime. So n will be even.
Okay.
Now we consider n plus 4. N plus 4 will also be even.
Okay.
And the main thing is n plus 4, it will have factor. It won't be a perfect prime power.
Hmm.
Oh, okay.
Right.
1 second, sir.
That is fine, I think. Okay. Right.
No. Yes, sir.
But it can be a
Actually,
perfect
yeah.
power.
And yeah, if it's a perfect power, then we consider n plus 6. So n plus 6 and n plus 4 can't both be perfect powers
They can.
because they're even.
Okay.
So they're even. So they have to be parts of 2. But parts of 2 can't be separated by 2 if n is
Correct.
greater than 10.
Correct. Correct. So either you take n plus 4 or you take n plus 6.
Yes, yes, sir.
Okay. Okay. Then
And we can show that f of n plus 4 is n plus 4, or if it's a prime power, then n plus 6 is n plus 6. And what happens is n plus 1 is prime, and n plus 3 is prime. So n plus 1 plus 3. So we can use this f of p plus q. So we get f of n plus 1 is n plus 1.
Okay, so n plus 4 is n, f of n plus 4 is n plus 4. But then, no,
Yes, sir.
then what do you do?
So then we write it as n plus 1 plus 3.
Oh, I
Now,
did this like that. Correct.
then n plus 1 is prime, 3 is prime. We apply that, we get what we want.
Okay, and similarly for n plus 6, 5 is
Yes, if n plus 4 is a part of 2.
there. That is interesting.
So like it's very close. But if n plus 1, and one more thing, sir, if n plus 1 is an odd prime power, then what happens is actually, one second, sir, n plus 2 is even. And if we assume Goldbach conjecture is true, then we can show f of n plus 2 is n plus 2. Like, I don't know if that's helpful, but we can show that.
Yes, yeah, but you cannot use it to prove n plus 1 is n. Correct.
Yes.
The methods here are, yeah, I understand. Anyways, but in either case, f of prime we have settled.
Yes, yes.
Yeah, it is so small moves. If we consider, so p square, so are we assuming that p is odd?
No, sir. Like,
Okay, so then
no, not
then
necessarily.
right. Okay, so then can we do for
It can be,
power of 2? Let us say that n plus 1 is 2 power k. Let's focus on this
okay,
case.
yes, sir.
Focus on small case. So you want to shift it by prime. So
Yes, sir.
yeah, you want to shift it by a prime so that it is not a prime power. Correct. That should not be difficult. This is probably not good. It's not shifting by a prime. So if you consider just this, then is it not done?
Okay. So we are considering n plus 3 then.
Yes, exactly.
Okay. Yes, sir. F of n plus 3 is n plus 3. We can show that.
Right. Just by your logic. And then
Yes,
again by
yes.
the same thing we can say, right?
But 2 power k is not prime. So we cannot apply that.
Oh, sorry. Yeah, this one is not mentioned for, okay, yeah, correct. Right. That doesn't work. Yeah, both the things, that was the advantage here.
Yes, yes.
Right. Uh, then what?
So actually, we can take a few examples. So like 9,
Hmm.
9, 16. But the advantage is 9, it decomposes as 2 plus 7. 16 is 13 plus 3. So those ones we can handle. But
Okay.
taking something like 20, 27. It
Uh,
cannot be written as a sum of primes. So
okay.
it's numbers like 27 that are
Right.
posing problems.
Okay. But then as you said, like with Goldbach's conjecture, this can be said also.
Yes.
Right. But
Yes, sir.
but doesn't seem to be useful to solve the other case. That's the problem. Like this 2 power k
Yes,
case
sir.
also we can do with Goldbach conjecture. Right. So that is easy, but
Right. Yes, sir.
but it doesn't lend any insight.
Yeah. And moreover, it's a conjecture, so I don't
Yes.
want to use it.
Yeah. Yeah, then this problem might also be a conjecture, right? It might be equivalent to
Maybe, yes, sir.
that. Like I don't know. Otherwise these conditions seem very strange. F of plus q is equal to-
So I'm just interpreting what he or she said. Like, I don't know if that
Right.
capital P is the set of primes or what. Like, it just intrigued me, so I started
Yeah, right.
solving it.
Uh, uh, right. But let's think about this a bit. Yeah, so we cannot use the shifting method unless we prove something stronger. Have f of 2 power k plus 2. Yeah, so then also wait. So, no, not f of 2 times. So this is something already known. This will be something.
Sir, if the GCD condition was removed, then it would be easy. And if this P plus Q, if it stood for, if it was, if P and Q are primes or prime powers, then also it would be easy. So it's
Yes,
these
with
conditions.
either of those conditions removed, it would be fine. Right. Yeah.
Yes,
If
yes, sir.
either of those conditions made prime power, it would be done.
Yes,
Right. That is fine. That is either of those. So these functions are called multiplicative functions. Right.
yes, multiplicative. And if you remove that GCD, I think it's called totally
Yes,
multiplicative.
totally multiplicative.
Yes.
Let us see. So, hmm. 2 power k. No. I this problem seems to be solved.
Yeah. Yes, sir. I don't have any more ideas.
Then you can try asking it there, maybe, right? On Stack Exchange.
So the thing is, the question got closed because it's oh, you mean you want me to ask it as a separate question?
Or maybe I would think that you should think about it for some days and then, yeah. Meaning that
Yeah, yes,
not like thinking consciously, but yeah, because it's
yeah,
better to also think
yeah,
on your own because it's not very important. This is not an emergency problem, right? then it's better
Right, yes,
to
yeah.
keep thinking about it, because
Yes, sir.
maybe you can try to read maybe multiplicative functions which are multiplicative and additive. You know.
Yeah. So this, I'm calling it prime linear. So because it's linear for primes. So like that.
Okay. Okay. Fine. And I don't even know if I've never seen this condition in my life.
Yeah, yeah,
Condition.
yes. It was new to me as well.
Yeah.
Yeah. But for solving the f of 2 equal to 2, it came like it worked very well. So I'm
Yeah, but
thinking
those
that
were
is what
very
the,
specific. Like those methods
yes.
were specific. Yeah, 5 and 3, but in general there is you cannot write uh, right. Yeah, because if we don't take p, okay, let's see though. If we so if we assume Goldbach conjecture, then f of 2 was done. Means f of 2 power k was done. Let us see if
Yes,
we can
sir.
somehow prove this. Is fine. Can we do something with this also? F of p power k. Okay. Somehow, even if we can apply Goldbach conjecture, then also.
So the immediate even number next to p per k is p per k plus 1.
Right.
So that we can show f of p per k plus 1 is p per k plus 1. So we can show that.
Of course. Right.
And we can show that for many even numbers actually. Like because from 1 to n, sorry, oh yeah, 1 to n, we have, so we can show it for many even numbers so that
Huh.
it is the identity
Means
for
many even
those even
numbers
numbers.
after p power k. There's
Yes, yes,
some
after p
extent.
per k. Yes, sir.
Yeah, certainly. That is. But then, so what do you do? Uh, so, okay, right. So power k is, even here, then power k plus- yeah, here even is not useful to use gold button.
Yeah, like we get p per k plus 1, and so p per k is sandwiched between these identities, but we don't know anything about p per k.
Okay, p power k plus 1 is, uh, right. Okay. What do you mean by sandwich? What is the bound?
So sandwiched as in p per k minus 1 is p per k minus 1, p per k plus 1 is p per k plus 1. So
Right.
this f of p per k is like in between these two values
We
where
cannot,
it is the
can we say that?
Yes, sir. So by induction, f of n, which is p per k minus 1,
Huh.
is p per k minus 1.
Right.
And if we assume Goldbach, then p per k plus 1 is p per, yeah. And p per k is in between those two. So I was just saying, like it's lying in between
But f
these
of
two.
this may not be in between, right? F of p
Yeah, yeah,
power
yeah.
k.
Yes, sir.
All right.
Yeah, that may not be in between. Like I'm just, like it might, I don't know.
Hmm. So if you assume so you can try to do this. You can try to do this. Maybe later you can think. If you assume that this function is identity, then can you prove Goldbach conjecture
Can we? Okay.
from this
No,
assumption?
sir,
No?
because this f of p plus q, it's not if and only if. So
Hmm. Right. No, I mean it won't be if and only because you will show f of n is n.
Yeah.
Fine. Yeah, that is nonsense. Correct. Yeah, sorry. That doesn't, of course.
Yes,
Yeah,
sir. So we won't be able to. Yeah.
yeah, that. That's probably. So what do you want to do next?
So other than this question, I was actually looking at TIFR sample paper, sir. So it's for the masters.
Okay. All right.
And so I saw the syllabus, sir, and they're saying uh, most of the syllabus is just like a standard BSc. So you have algebra, analysis, and other
Yes,
basic concepts like
it is just
pigeonhole and
that.
all that.
Yes.
But there was topology, sir, and actually, if depending on which college I go to, I may or may not have topology as a part of my bachelor's.
Not a problem. No, you can read it.
So, like, I don't know.
That's
Yes,
not
yes.
easy.
So when I was thinking, so
Mhm.
how long would topology take, sir? Like, if we are done with analysis, then
Right.
so would
Yeah,
one
so
summer be enough?
yeah, certainly. I think
Okay. Yes, sir. Yes, sir.
will not get.
So,
Depends
and
on
I
how much.
saw
Depends on how much policy you want to know. Right. Yeah, but
yes,
for
yes, sir.
yes. So like don't think of it in terms of time. Okay. The point is that as you study analysis more and more, you will see that topology will be needed to understand
Oh,
analysis better,
right,
and
right, right.
then it will naturally come to play its role.
Okay. Yes, yes, sir. Yes.
So anyway, so you have your question. So why don't we take a break, right? And then
Yes, yes, sir.
we can try those problems.
Yes.
So
Okay, sir.
yes, and if you want to see topology, the first step usually is to like when you are doing this real analysis, first you're doing on the line, right? Real line. So when you read Bartel and Sherbet, right,
Yes, sir.
you will see that a lot of things that you prove for the real line are also true for the plane. Okay, but the proof may
Okay.
become more difficult because in the real line you have an order, right? And you also have a division
Yes.
structure where you can divide number, invert, x invert, right? But in the plane, I
Yes.
mean, yeah, it depends on whether you reduce complex numbers or not. So you don't, at least you do not have an order, right? You do not have an order. You have some order, but they don't gel with the addition and multiplication structure, right? So basically,
Yes.
what happens is
Yes, sir.
that a lot of things which are true in the real line are also true in the plane, but you have to formulate them properly, and the proof you sometimes you have to do them without using the order form. Okay.
Okay.
For example, you know that any sequence of real numbers has a monotonic subset,
Yes. Yes, sir.
right? And that you have seen, right? That you can try to prove. You're not. And that basically is useful to show that given any bounded set, it has a supremum, it has a least upper bound. Right. Now, when you try to prove the same
Sir,
property,
sir, your voice is breaking. Can
okay,
you repeat what you just said?
right. So I was just trying to give an example. So, for example, you say that the real line, right? The real line in the real line, the sequence in the real line. If you have any sequence in the real line, it has an increasing subsequence, right?
Yes,
And that is
monotone. Yes, sir.
right, monotone, right? And that is useful. That is useful in what way? Think about it. How is it useful in analysis?
Sir, actually, now I can't hear you.
Okay,
Like your
okay.
voice is very.
Okay, so let's take a break and then we will try to fix
Yes.
it. Yeah.
Okay. Okay.
Okay,
Yes,
okay.
sir.